Hey guys, Mr. B here, and welcome to another virtual lab. In this lab, we're going to be doing the anions and cations lab. So, let's get started. Alright, so in this lab, we're going to have a lot of different chemicals we're going to be dealing with. We're going to be taking very small amounts of each one of these, and we're placing them into, oh geez, that was an uncomfortable noise. We're going to be putting them in this spot plate here and mixing them up, and we're going to see if any chemical reactions occur. And if so, we are then going to write down the chemical formulas and the names of the compounds that form in the spot plate when we see a reaction. Here we go, let's get started. Alright, we are here with the first table, part A or figure A of the anion analysis. We're going to be doing this one first. So we got our empty spot plate, and we're going to start filling up with chemicals. Alright, so first up, we are going to add a little bit of sodium sulfate to 3 of these wells in the spot plate. So we'll put a couple drops in this one. We're going to put a couple drops in this one. And then lastly, we're going to put a couple drops in this one. Let's make sure we use all of this sodium sulfate up. Let's make sure each one has got plenty. There we go. All right, next up, we're going to take a little bit of nitric acid, and we're going to add that into the 3 spot plate wells in the middle. So let's again add some to the top one. We'll add some to the middle one. We'll add some to the bottom one, and we'll just kind of even each one out here a little bit, just make sure that we use up all the nitric acid in our dropper. All right, there we go. All right, now thirdly, we're going to add some sodium phosphate to our 3 wells on the far right-hand side. So again, let's add some to the top, add some to the middle, and we'll add some to the bottom. And again, we're going to make sure that we even each of these out a little bit, just make sure that there's plenty of sodium phosphate in each one for our reactions to take place in the next part. There we go. Alright, so for our first reaction here, we're going to add some silver nitrate into the top row with the sodium sulfate, nitric acid, and sodium phosphate. So here we go. First off, we have the silver nitrate and sodium sulfate. Alright, so do we have any observations we can make? Do we see any change occurring? I definitely see something. Let's add it to the nitric acid. Okay, so again, are we noticing anything there? And then let's add it to the sodium phosphate. And now again, are we noticing any change occurring? So make note on your lab sheet what of these 3 wells had a change occur. And we'll move on to the next part. Alright, so for this middle row, we need to add a little bit of iron into our spot plate wells. So I just have a bottle of iron here, some iron filings. So I'm going to add a little bit into each well. And then from here, we are going to add hydrochloric acid. And again, we're going to make note if we see any kind of chemical change occur. All right, so let's add in our 6 molar hydrochloric acid. Here we go into the first well. So this is hydrochloric acid with iron filings and sodium sulfate. So again, do we notice any change here as we add this hydrochloric acid in? Okay. Then we have our hydrochloric acid and iron filings with nitric acid. So add this in. Again, do we notice any change here? And lastly, we have our hydrochloric acid with iron filings added to the sodium phosphate. Again, do we notice any changes occurring in any of these 3 wells? Make sure we add enough hydrochloric acid in each one, just to make sure we have enough. All right, so make down any observations, and we'll move on to the next part. All right, so it has been a little bit of time here, and I really want to take a look at this one here in the middle with the iron, hydrochloric acid, and nitric acid. Now, at the beginning of these reactions here in the middle with the iron and hydrochloric acid, there really wasn't much going on. But after they've sat for a while, I do actually see that there has been a little bit of change. So the coloring here for this one in the middle is a bit yellow looking. And there are definitely some bubbles that have formed on the pieces of iron that are in there. So there's some kind of gas potentially that was produced, as well as, again, we do see a color change. So just wanted to point that one out. We're going to keep on moving though on to the next one. All right, now for the third part, we are going to add in lead 2 nitrate into the sodium sulfate, the nitric acid, and the sodium phosphate. So here we go. Again, lead 2 nitrate being added to sodium sulfate. Do we notice any change here? Let's add it into the nitric acid. Do we notice any change there? Let's add it into the sodium phosphate. Do we notice any change occurring there? So again, let's make sure we add enough in each one. I definitely see some changes occurring in some of these, so hopefully you're making the same observations I am and the camera is picking them up well enough. But if not, we will definitely talk about them in the post-lab discussion. All right, so we're here now with figure B, or part B of the lab, doing the cation analysis. We're going to fill up these first 2 spots with some potassium iodide solution. Okay, so we're going to add some here, again, into each one. Just make sure roughly each one has about the same. All right, and we're going to move on to fill up the next ones with the next chemicals. All right, we're going to fill up these middle 2 here now with some calcium chloride solution. So again, we'll add a few drops into each one. Just make sure that each one has about the same amount. All right, looks about good. There we go. We'll move on to filling up the last one here. All right, so now in the last spot plate wells, the last 2, we are going to be adding some iron 3 chloride. So we'll add a few drops into each side. And make sure each one has about the same amount. And there we go. All right, so now from here, we're going to add in sodium hydroxide and potassium thiocyanate. All right, so we're going to add in some sodium hydroxide now into this first top row. So this first one, we have sodium hydroxide with the potassium iodide. Do we see any kind of reaction happening? Then we have sodium hydroxide now with calcium chloride. Do we see any kind of reaction? And lastly, sodium hydroxide with the iron 3 chloride. Do you see any kind of reaction? So again, make some observations, write down on your sheet if you see any kind of change occur, and we'll make note of it. All right, the last one now we have to do is potassium thiocyanate here in this bottom row. So we're going to have potassium thiocyanate with potassium iodide. Do we see any kind of reaction occur here in this one? We have the potassium thiocyanate with the calcium chloride. Do we see any kind of reaction occur? And lastly, the potassium thiocyanate with the iron 3 chloride. That one I think is pretty obvious. Something is occurring in that one. So again, make down your observations, and we are going to move on to the post-lab. All right, so we are done now with the lab, and we are back in the classroom, and we are going to take a look at the post-lab questions for this lab. Now, on your sheet, you should have these data tables filled in. So if something happened in these spot plates, you should fill it in with, it turned yellow, or turned white, or cloudy, or nothing happened. So we should have some data here. Mine's blank, but hopefully you have your data written down on yours. So we're going to take a look at some questions. Okay, so here, number 1, it says, carefully examine the reaction of FeS and HCl in the presence of HNO3. What is unique about this reaction? How can you use it to identify a nitrate ion? So this one was with, it was in part A, and it was actually this middle one. So we had HCl with the iron, and they have the HNO3 in the middle one. And this was the one where at first nothing seemed to happen, but after a while there was a bit of a yellow tint to the liquid, and there were definitely some bubbles or some kind of gas that was forming around the iron powder that was in there. So what interesting part about this one that we can put down is the reaction caused the solution to turn slightly yellow. Also, there were bubbles that formed around the iron powder in the spot plate. Yeah, so it basically answers the question of what is unique about it and how can you use it to identify a nitrate ion.
basically the evidence of what it does, right? The clues of what it gives. It turns yellow, gives bubbles, is what we can use to identify nitrate ion. So, all right, number 2, which solutions from figure A are the best for identifying each anion? Which solutions from figure B are the best for identifying each cation? And explain. So basically what this question is asking is, in figure A, or part A of the lab, the anions that we had are these ones. So we have SO4 2-, we have NO3-, and we have PO4 3-. So this is a sulfate ion, a nitrate ion, and a phosphate ion. And the question is basically asking, of these 3 solutions that we used, so silver nitrate, AgNO3, the hydrochloric acid with the iron, and the lead 2 nitrate, or the PbNO3, of these, which ones kind of gave you the best results or did something when you mix them together and gave you results, right? So in the first one with the silver nitrate, I'm pretty sure the silver nitrate with the Na2SO4 kind of turned a little bit white. Okay, it was sort of faint, but it did turn white. So this one would be a good one. Now, if you did this lab in person, maybe you didn't see it turn white. The middle one, the AgNO3 with the HNO3, nothing happened. So that would not be a good one. But then the last one, the AgNO3 with the sodium phosphate, turned yellow. So this one would be a good one also that we could use to identify the anions. So again, the question was asking, which solutions from figure A are the best for identifying each anion? The silver nitrate was pretty good at identifying the anions for sulfate and for phosphate. For the HCl, nothing really happened in the first spot plate, so nothing really happened with the sodium sulfate there. For the nitric acid, this one turned yellow, so this one is actually pretty good. So the HCl with the iron is pretty good at identifying the nitrate ion. But then for the phosphate ion with the sodium phosphate, again, nothing really happened. So the HCl and the iron is really only good at identifying the nitrate ion, and it was not very good at identifying the other two. And then lastly, with the PbNO3, the first one I'm pretty sure turned white. We'll have to re-look back at the footage, but I believe this one turned white. The middle one did nothing, so the lead 2 nitrate was not good at identifying the nitrate ion in the nitric acid. And then the last one, I believe, turned white as well. So the lead 2 nitrate is pretty good at identifying the sulfate ion and the phosphate ion. But again, you need to review your data as well. Okay, so this is going based on what we saw in the video. But if you did this in person, you'd be reviewing your data, and you would then answer those questions based on what you saw, and basically just put down which ones were good. Okay, so for figure A, you can basically say that AgNO3, I'm going to do the little subscript button, there we go. AgNO3 was good at, make sure that our subscript is off, was good at identifying the SO4, so the SO4 2- ion, and the PO4 3-, so the phosphate ion and the sulfate ion. Okay, so AgNO3 was good at identifying the SO4 2- and the PO4 3- ions. We say HCl was good at identifying the nitrate, so the NO3- ion. Excuse me. And the PbNO3 2, make sure we write this correctly here, was good at identifying the same two ions that the silver one was good at. So we're just going to copy paste here. So copy paste there. And here. So, and the, okay. And then for figure B, and maybe we'll move this text over a little bit. For figure B, okay, so again, same thing here for figure B. We are identifying the potassium ion from the potassium iodide, the calcium ion from the calcium chloride, and the iron 3 ion from the iron 3 chloride. Okay, so in these ones, again, you need to look at your data. But in our video, I believe this first one, we had nothing happen. So the sodium hydroxide, NaOH, was not able to identify the potassium ion. As for the middle one, I don't believe anything really happened either for that one, so nothing. And then for the iron 3 chloride, this one turned yellow. So it looks like the sodium hydroxide is good at identifying the iron 3 ion, but that was about it. As for the KSCN, for the first one, nothing really happened. So the potassium thiocyanate was not good at identifying the potassium ion. It also was not good at identifying the calcium ion because, again, nothing really happened with the calcium chloride. However, it was really good at identifying the iron ion in the iron 3 chloride because when you put these two together, it turned like that really blood red kind of color. It's very cool. So, so for figure B, we will say the NaOH was good at identifying the was it the iron 3, the Fe3 plus ion, so the Fe3 plus ion. And then we can also say the KSCN was good at identifying the, there we go, the Fe3 plus ion. So they were both good at identifying the iron 3 ion. There we go. Okay, so that's what the question is asking. All right, lastly, number 3, can your experiments conclusively identify K plus ions? And it says explain. So the reaction that we had for the potassium was between the potassium iodide and sodium hydroxide, and nothing happened. And potassium iodide and potassium thiocyanate, nothing happened. So did we have any good tests that could identify if potassium ions are present? No. Okay, so can your experiments conclusively identify K plus ions? No. And then it says explain. We say no because no chemical reactions occurred in any of the experiments that we performed. Okay, so no. All right, and then the You're the Chemist part just has you write down your observations, which you probably already wrote down your observations up here in the data table. Okay, all right, so that is it for this lab. Hopefully that helps you understand what the questions we're asking. And again, this is just a little experiment just to kind of show some of the reactions between different ionic compounds and forming new ionic compounds. So, all right, guys, that's it for this one. I'm Mr. B. Thanks for watching, and I'll see you in the next one. Bye.